Question 1. The project from part 1 is released from rest and slide down along the smooth ramp as shown in figure 1. Given y0 is taken from value in part 1. So, the object from part 1 is earphone pouch, which has a mass of 0.030 kg, and the y0 from part 1 is 0.474 meter. Question A asks us to sketch the free body diagram of the object. So, we have the weight going downward and a normal force acting on the object as the force going down the smooth ramp. And the kinetic diagram is shown on the right side, which is the force is equal to ma. So for question B is to calculate the speed of the object just before it leaves the surface at P. So we need to obtain our information, which is mass equal to 0.030 kg. VA is equal to 0 because it is the initial velocity. And the gravitational force is 9.81 meter per second squared. And we need to find the VB. So we can obtain the speed by using the equation 1, which is the conservation energy theorem. So it can be written down as 1 over 2 mvh squared plus mgh equal to 1 over 2 mvb squared. So we just need to put in the information we have into the equation. So 1 over 2 times with 0.030 kg times with 0 squared plus with 0.030 kg times with 9.81 meter per second squared times with 3.5 meter minus with the y0. Our y0 is 0.474 meter and it is equal to 1 over 2 times with 0.030 kilograms times with VB squared. On the left hand side, we obtain 0.8906 equal to the right hand side 0.015 VB squared. The VB squared is equal to 59.3733 and the square root of the VB squared is 7.7054 meter per second. And this is our speed of the object before it leaves the surface at P.
For question C, calculate the distance from the wall of the ramp at B to where the object strikes the ground. First, we use kinematic equation for vertical and horizontal. For vertical, y equal to negative 0.474 because the object is moving downward. So, negative 0.474 equal to 0 plus 1 over 2 times g negative 9.81 times t square. So we get t equal to 0.3109 second. For horizontal, the equation is x equal to x naught plus v naught x times t. So v naught x we change to vb. Vb is equal to 7.7054 that we get from question 1b. So times t that we get from vertical is equal to 0.3109. So xb is equal to 2.3956 meter. For question D, speed at which the object hits the ground. So we use conservation energy equation, and then the height is 3.5 meter. So the velocity final is equal to 11.3156 meter per second.
Next, for question 2, the object from Part 1, which is ball released from rest and slides down along the smooth tram as shown in figure 2. Below diagram is the figure 2. Note, assume y0 equals to 1 meter if y0 equals to 0 meter in part 1. The horizontal velocity v1 is equivalent to the speed of the object just before it leaves the surface at B. Take exponential e equals to 0.7. For question A, the question asks to calculate the velocity of the object just after it rebounds from the ground. First, we must use projectile motion equation, which is vcy squared equals to v1y squared plus 2ac multiple sc minus sy naught. First, we let sc equals to 0 and v1y equals to 0 to find vcy. Then substitute the value into the equation. We got vcy squared equals to 0 squared plus 2g 0 minus 1. We take g equals to negative 9.81 since it's going down. So substitute the g inside the equation. We got vcy squared equals to 0 squared plus 2 multiple negative 9.81 multiple 0 minus 1. Then we solve the equation. We got vcy equals to square root of 19.62, and the final answer we got for vcy we got negative 4.4294 meter per second, or 4.4294 meter per second going downwards. Next, we calculate the vcy2 by using the coefficient of restitution formula, which is E equals to vg2 minus vcy2 over vcy1 minus vg1. Given the question E equals to 0.7, substitute the value of E as 0.7 in the equation, and we got 0.7 equals to 0 minus vcy2 over negative 4.4294 minus 0. Then solve the equation to find vcy2. We got vcy2 as equal to 3.1006 meter per second going upwards. By using principle of impulse and momentum equation, which is mava1 plus mbvb1 equals to mava2 plus mbvb2. Next, to find acceleration, we use the conservation of momentum formula, which is m1 v1 equals to m2 v2. We substitute the value. We got v1 as is 7.0036 equals to vcs. Therefore, we got vc2 equals to 7.0036 I plus 3.1006 J. Next, we calculate the magnitude of vc2 equals to square root of v.0036 squared plus 3.1006 squared equals to 7.6593 meter per second. For question B, the question asks to compute the maximum height to which the object rises after the first bounce. By using kinematics equation vertical motion, which is v2y squared equals to vcy squared plus 2gs2y minus scy. Then substitute the value inside the equation, which is v2y is 0 equals to 3.1006 squared from this equation plus 2 multiple of negative 9.81 multiple of h minus 0, since we want to find the height, maximum height. Then simplify the equation. We got 0 equals to 9.6137 minus 19.62h. Then we arrange the formula that we got 9.62h equals to 9.6137. Then the final height we got 0.49 meter.